In this video, we'll discuss frequency tables. Now, a frequency table is a table that shows intervals, which are also known as classes, with data and the count of that number of entries for each of those intervals. So we have an example here on the side. Now, the frequency is the number of data entries that occur within that interval. So like here we could say that from 1 to 5, that occurred 5 times for whatever they were measuring. Now the class width we find by subtracting the lower limits of 2 consecutive classes. So here we would say that here's our lower limits and our upper limits. And if we do 6 minus 1, we will get that the class width is 5. You could do the same thing with the upper limits as well, just most commonly it is done with the lower limits. But 6 minus 1 is 5, and 10 minus 5 is 5 as well. So use whichever makes the most sense, but it has to be from one class to the next to get that width. Now when you construct your own frequency table, we first decide the number of classes that we need for the table. Often this is somewhere between 5 and 15 number of classes, and a good way to estimate that would be to say how many entries do you have and take the square root of that and get approximately that number based on the nearest whole number. To determine the class width, we first need to find the range of our data, then we divide that by the number of classes, hence why we start with the classes first. Now this isn't always going to give you a whole number, so we round to the next convenient number. Next we need to create the upper and lower limits. We actually start with the lower limit. The first class will include the minimum from our data set. That was where we start. Then we use the class width that we determined in part 2 to create each consecutive lower limit. And we get all of them until we have the number of classes that we need. Then to create the upper limits, we say from the next class, lower class, we want to go right before it in the previous upper class. So if we go in like our previous example, it went from 1 to 6. That's why the previous class upper limit was 5, because it was 1 less. But whether it's a whole number or a decimal just depends on how your classes are split. And we keep doing that process. We just want to make sure there is no overlap between classes. That's a very important thing. Once we have our classes, we just count up our data and mark the number of items for each of the individual intervals or classes. So say we have this data of 50 customers and we're told we want to create a frequency distribution with 7 classes. So here we're given that we want to start with 7 classes. And honestly, if you took the square root of 50, it's about 7. So that's why 7 is a good number here. Now we need to find the class width. So we need to find the range and divide that by the number of classes. So if we remember, our range is always our greatest versus our smallest value. Here, that would be 86 and 7. And if it helps, you can always take your data and order it if you want. Just when there's large sets like this, I kind of say, okay, this is small. Do I see anything smaller? This one's pretty large. Can I find one larger? So I'm going to take my range, so I subtract those two values, and then I'm going to divide by the number of classes, which is 7. That gives me 79 sevenths, which is about 11 and 29 hundredths. So I'm going to go in and round up to 12 because I find that to be the easiest way to go often is to round up. So I'm going to have a class width of 12. Now I can go in and put my lower and upper class limits together. I'm going to start with the lower and say, okay, for my lower, I need it to be the smallest value that I said. In this case, the minimum was 7. Now I'm going to add my class width, which is 12, to create the next number. So I'm going to go from 7 to 19. Now I'm going to add 12 more to create the third class, which is 31. Add 12 more, give me 43. Add 12 more is 55. Add 12 more is 67. And then 12 more gives me 79. Now why do I stop at 79? How many classes did I want? I wanted 7 classes, so 1, 2, 3, 4, 5, 6, 7. I have all my lower limits. Now I need to create my upper limit. So I'm going to say I want to be one less because all of these are whole numbers. I'm going to be one less than my next lower limit. So if I look at 19, say one less than that is 18. If I go 31, one less than that is 30. If I go 43, one less than that, 42. 55, one less than that's 54. 67, one less is 66. And 79, one less is 78. And then I can say, okay, the last one then would have to be 90. Now, if you're unsure about that last one, here's the other great thing to remember. When I go from 18 to 30, that was also 12. So when I'm going from 78 to 90, I'm just going to add 12 to make that up, to get that final class limit. So the class width is the same between the lower limits as well as the upper limits. Last thing then is to find the frequency for each class. So I'm looking for all of my numbers between 7 and 18. And I'm just going to go left to right, top row to bottom row. So there's one number, two numbers, 3, then 4, 5, and 6. So there's only 6 total, so I'll put a 6 there. And the other way some people like to do is they like to start with tally marks and then change that to an actual number. That's fine to do as well. Next one, I'm looking for any number from 19 to 30 included. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 total. Then I'm going to go 31 to 42, just going left to right. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 13 in that frequency. From 43 to 54, I'm going to do the same thing. I'm just going to cross them out. There's 1, 2, 3, 4, 5, 6, 7, 8. From 55 to 66, and you can see it becomes easier because there's fewer numbers there to cross off. I've got 1, 2, 3, 4, 5. And then from 67 to 78, I've got 1, 2, 3, 4, 5, 6. And then I can see, well, what's left? 86 and 80, so that gives me 2. So it takes a little bit to create a frequency chart, but I just take it one piece at a time, start with those lower limits, then create the upper limits, and then start to slowly count my frequencies. Now, what all can I do with those frequency tables? I can actually find the mean, the median, and mode from a frequency table. But to do this, I first have to find the class midpoints. To find that, I take my upper limit and add my lower limit and divide by 2. In other words, I'm finding what's the midpoint, the literal midpoint between those two upper and lower limits. Now to find the mean, I take my midpoint and multiply it by each frequency. I add up those values, and then I divide by the total frequency. In other words, the total number of entries. So I have to use the midpoints and then times the frequencies, add it up, divide by how many entries there were. If I want the median, I determine what would be the literal middle of my data, what entry number. And then I'm going to use those midpoints and I can count the frequencies until I get to that actual midpoint. And then for the mode, I'm just looking at what class or class midpoint has the highest frequency. So you'll see the mode reported 2 different ways, just depending, and both of them are appropriate. So let's go back to our data here. We have all the data we need. Now let's find the mean, the median, and mode for this. Step 1, we find our midpoints. So if I take 18 plus 7 and divide by 2, that's 25 halves or 12 and a half. And I'm going to do that for each of these so that this one's 24 and a half, 36 and a half, 48 and a half, 60 and a half, 72 and a half, and 84 and a half. And you should notice that from one class midpoint to the next is plus 12 because that's the class width. So my midpoint should also follow that width. This is how I know I'm doing everything right. My lower limits are 12 apart. My upper limits are 12 apart. My midpoints are 12 apart. That's a great way to check what I'm doing. Now to find my mean, I'm going to take my midpoint and multiply by my frequency, and I'm going to do that for each of these. So midpoint times frequency plus midpoint times frequency plus midpoint times frequency for all 7 classes. And then I divide by, well, how many entries were there? There were 50. And I could double check that by adding up all my frequencies here, but it stated that in the first problem. So that gives me a total of 2,089. When divided by 50, that gives me 41 7/800ths, which makes sense because it's somewhere in this class. And if you look, most of the data is right there between 9 to 30 and 31 to 42. Now, if I want the median, I want to find the literal middle of 50 entries. Well, the median would have to fall 50 divided by 2 around the 25th entry. So I'm going to go through and count frequencies. So 6 plus 10 is 16, and then I need to get to 25, so I need to go 9 more. Well, this takes me 13 more, so I'm in this class right here, which means that I'm in the 31 to 42 class, which means the median would be 36 and a half. I could come from the other direction as well. 2 plus 6 is 8. 8 plus 5 is 13. 13 plus 8 is 21. And then to get to 25, I have to go into my next class, which puts me in the 31 to 42 again. Now to find the mode, I'm just looking for what class has the highest frequency. That would be 13 right here. So that class is 31 to 42. Or I could say the class midpoint, which is 36 and a half.